Alright, last video of this chapter besides the review. So we're going to get right to this. I said I was going to be quicker today, so I'll do everything I can to keep this video short and sweet. First of all, if you have to, pause these and write down these two definitions. Also, you need to download the new notes. So if you printed the whole packet, I'm sorry, there were some changes, but the changes were good. We made it simpler for you. So you can either compare the two and make the changes if you want, or I would just suggest you're going to need to reprint the new packet. So I'm sorry, had to print a few more pages this chapter. So anyway, we have a regression equation, which we talked a little bit about yesterday. It's an equation written as y equals mx plus b that best fits a set of data. So you can see over here, we have our regression line or our trend line. And I even used the word yesterday, we were talking about the line of best fit. I just incorporated that into our definition. And then the new thing that we're going to be dealing with today is our R value. Technically, it is called the Pearson's correlation coefficient. And that just tells us how strong the correlation is. If we were in class, we would be doing this with calculators and putting scatter plots in. And we use the stats program on a graphing calculator, and it tells you how strong the relationship is. Because we don't have that availability this year, we're just going to give you the R values and the equations, and then you just need to tell us what's going on. So the R value, if we have a perfect score of 1, that would be one where everything fit exactly on the line, and it would be a positive slope. This one here would be a negative slope, and it would be a perfect correlation again where everything fit exactly on the line. So if we look at this one here, you can see that it's a positive 1. This one would have probably an R value, somewhere in here. So in general, I think we look at like that 0.75 mark. Anything above 0.75 this way would be a strong positive relation, and then everything negative 0.75 to 1 would be a strong negative. And then if we got into the 0.5s, this would be probably a weak negative 1, and this one would be a weak positive 1. And if we get in between the 0.5s, there's really no correlation that would help us. So if I scroll back, I can't scroll back because I'm in a new note packet, but when we go down here and we look at some of these examples, you can see how close this data falls right here. Age and weight of a panda. This one here has a correlation coefficient of 0.998, so it's really close to 1, and if you look, all of these points are pretty much touching the line. And here's your y equals mx plus b equation. So it says, what type of relationship does this show? Okay, it shows a positive relationship, and it is a strong one. So you could say positive, or you could say a positive correlation. And how do we justify our answer? Well, really all we just need to say is it's close to positive 1. That's it. You could be more detailed. You could say that all the data is really close to the line. So it says most pandas are really grown around 4 years old. So it says predict the weight after 4 years. So I will plug that into my calculator real quick. As we calculate this one, you have to be careful because this is 4 years old. But if we look up here, it is age in months. So I had to do 12 times 4 is 48. 4.64 times 48 minus 1.2 0.27 is 221.5 pounds. So actually, this is the second time I did this part, so I'm going to edit it out. So if the video kind of skips, that was why. You got to be careful of your labels. So we'll do one more here, and then we'll call it a day. So you'll see here again that this is close to 1. So this is a strong negative correlation. It's close to -1. And we're doing altitude of an airplane and outside temperature. So as you go further up in the air, the temperature goes down. So they want you to use the regression equation to predict the temperature outside the airplane when the altitude is 4,800 meters. So if we look here, 4,800 would be here. So right now, we're probably going to guess it's going to be somewhere around 10. So let's see what happens. So this 10 was a good guess. I paused it again just to try to save you guys some time here. Here's the equation from here. I just copied it down here. Put my 4,800 in for X. And we're going to get an outside temperature in Fahrenheit of 10.1 degrees Fahrenheit. So I'm going to skip 3 and 4 so you don't have to worry about those. So we're not doing number 3. We're not doing number 4. And now what happens here is that you have to find the equation. So if we're on to our notes, I'm going to set up this. No, I want you guys to do that, sorry. This will incorporate what we did yesterday. So find the equation. So I would just use y equals mx plus b. And we'll call this looks like, probably goes through, it's got a y-intercept of 8. And then you could pick a couple points, like maybe here, and try to find another one, maybe here. And those go right through your squares, and you can do your rise over run there. So we're going to start, this is on page 27. You're going to do 1 through, I believe it is 11. But a lot of these are just, if it's strong or weak, and then you plug in one thing into the equation, just like we did on our notes. Couple review questions on 10 and 11. Notice how this one says point slope and this one says slope intercept form. Those are good review questions as we head into the final exam. So you're starting again on page 27, going 1 through 11.